Okay, we're going to work on conditional probabilities, and one of the techniques used to solve these types of problems are two-way tables. I'm just going to tell you they are a fantastic tool. After you've practiced them a few times, you'll do well at it. Initially, you kind of stumble. I will admit to that. It's not easy initially, so you're going to have to practice this. So please pay careful attention, and I will point out to you the pitfalls. But there's a step-by-step process to this, and if you follow it, you're going to do very well. As you remember, or may not remember, when we talked about two-way tables before, the numbers inside the middle of the table are the conditionals. This is the total. The numbers on the outside are the marginal probabilities, okay? So let's start with a scenario. Consider that 2% of the patients are known to have cancer. A blood test is developed that is positive in 98% with cancer, but also positive in 3% of patients who do not have cancer. So identify the two variables. Well, our two variables in this case are the test results and your cancer status. Either you have cancer or you don't, and the test results are either positive or negative. Please remember, test results can be wrong. Okay, so that so you can test positive when you don't have it, and you can test negative when you do. So it's not always perfect. When we set this table up, and by the way, they're not going to give you this diagram. You're going to have to set it up yourself, and you'll just make a picture window off to the side and start filling in. And we'll get some practice with that here later, but that'll be part of another video, separate video. The main thing I need to do is I need to read my scenario, and I'm going to read the scenario and then identify the one number that is not contingent upon something else. In other words, it's not conditional. It's just period. It's factually that. Whatever that number is, that's going to be in my column status. All right, just makes life easier if you put it in columns. So suppose 2% of the patients are known to have cancer. When I read that 2%, we know that they are known to have cancer, and we don't relate it to any way in the test. There's no ifs or ofs or anything. They're just known to have cancer, period. That looks pretty good. That's probably my number, but let's read on and let's make a contrast. So a blood test is developed that is positive in 98% of patients with cancer. Oh, so we hear this 98. This 98 is tied to positive and is tied to cancer. That's two variables. I need only one variable. I need to identify the number with only one variable. So let's look at this one. But it's also positive in 3% who do not have cancer. So once again, it's positive, do not, two variables. So when I go back and go, uh-oh, let's check this 2% out one more time. 2% of the clinic's patients are known to have cancer. That is tied to cancer only. It's not tied to positive, negative, or anything else. So they know that 2% have cancer. So we're going to go ahead and write that number here because this is the cancer status. And by the way, if we were making a table, we always put that number here, and then we build the table around it. So this is 0.02, and then 1 minus 0.02 is 0.98. So I can go ahead and fill those numbers in. And those are big numbers or marginals. I can write them large. Now, this is very simple, but I need you to pay attention to what I'm going to say here. Write those numbers small and just bring them up the column. So this is 0.02, so I'm just going to write it small. And I'm not even going to worry about it. Just going to write it small and put it there. This is 0.98. I'm going to write it small, and I'm going to fill up my column. Now, I wrote it small because I'm going to have to do some other work. All right, I'm going to have to do some other work. So let's go back and look at it. A blood test that is positive in 98% of patients with cancer. So positive, so we're looking at the positive, and with cancer, and that's right here because that's positive and with cancer, so this is 0.98. And at this point, we're going to go ahead and multiply that out. So 0.02 times 0.98, and this is 0.0196. And I may have made a mistake, but I'm going to try this out. So this is 0.0196. Okay. Now, because that's 0.98, this is the complement, 1 minus 0.98. So this is going to happen to be 0.02. All right. So 0.02, so 0.0004. Now please check yourself. This plus this equals that, and it does, so we're good. All right, continuing right along. It's also positive, so we're still looking at the positive row, so still looking at the positive row, and 3% who do not have cancer. So this is going to be 3%, 0.03. The complement of that is 1 minus 0.03, which is 0.97. I wrote that a little bigger than I meant to. Let's go ahead and multiply 0.98 times 0.03. And we get 0.0294. And I'm going to add that to this 0.0196, 0.0294 plus 0.0196. And I know my screen doesn't show that very well, but this is going to be 0.049. And it just came this plus this equals that. And then I'm going to go ahead and do 0.98 times 0.97, and that's 0.9506. And this plus this equals 0.951. And if I add these two values together, they should equal 1, just like these two equal 1. So basically, rows and columns all need to sum together. If they do, there's a very high likelihood you set the table up. All right, so what is the probability that the test is positive? Well, that's pretty easy. I can just look at the positive row and go, you know what? 0.049 over 1. So that just equals 0.049. The marginal over the total. What is the probability that the test is negative and the person has cancer? So negative and has cancer. So I need to look at negative and has cancer. And I'm just going to do this on a separate sheet of paper so you can see it, because I don't want to take the table off the screen that we worked so hard to make. So B is negative and has cancer. So negative and is the intersection word. Please don't forget that. So 0.0004 over 1 equals 0.0004. All right. The next one, part C, given. Well, we know that given is always in the denominator. So we have given in the denominator, and we're going to have some sort of intersection in the numerator. Given the person has cancer, so now we're looking at the cancer column. And what percent have cancer? 0.02. So 0.02, given they have cancer, what's the probability the test is negative? So now I'm looking at the intersection of the two, where they cross. Remember, intersection is where they cross. So you're looking for some sort of intersection And so you're looking at the intersection of negative and cancer. So this is cancer, this is negative. My intersection is 0.0004. So 0.004 over 0.02, and my answer happens to be, there's a 2% chance that that will happen. Part D. Go to another slip of paper. If a person who is chosen at random from the clinic's patients, so out of the population, is given the test and it comes out positive. Ooh, so the test is positive. What is the probability the person actually has cancer? So once again, we have a given. And what are we given? Test comes out positive. So given's always in the denominator. We'll have an intersection in the numerator, so where they cross. So given that it's positive, so 0.049, what is the probability that they actually have cancer? So we're looking at the positive row, and then we're looking at has cancer. So this is 0.0196, and this equals 0.40. All right. Okay, so that sort of ties that up. I am going to go back to doing this table, just show you what it would look like on a test. On a test, they're not going to give you that table to fill out. You're going to have to figure out how to do it. So here's what I would do. So I know if I recognize it as a table problem, and basically when they give me numbers and they give me several of them, I go, you know what, I'm going to use a table and see if that helps me organize it. I may be wrong because it doesn't always help. I mean, it may not be a table problem, but I always find that it's a good place to start as far as organization. So I could start off by doing this. I make what I call my window. There it is. Nothing fancy, nothing special. Now with my window, I know one number before I start. I know this is 1.0. I go ahead and extend this, and I go ahead and extend that. 2% we already identified as being the one variable. Because it's one variable always goes right here every single time. So make this spot every single time where you put the one variable, and then the one minus that goes here. Well, 2% had what? They had cancer, and I'm usually lazy and I try to abbreviate, so cancer and no cancer. And then we know we have tests that are positive and negative. And once I have that, I've done the hardest part of the table. I haven't done the work, but I've done the hardest part, because I'm just going to write 0.02 right here. I'm going to write 0.02 right here, 0.98 right here, and 0.98 right here. And then from that point on, I'm going to start filling in. A blood test, can't see my question, thank you. A blood test is developed that is positive 98% of the patients with cancer. So positive with cancer is right here. 1 minus 0.98 is 0.02. By the way, it just happened that these are the same numbers. Normally they won't be, it just happened to be in this particular case. It's also positive in 3%. So another thing, we're looking at positive again, who do not have cancer or no cancer. So 0.03, and the complement of that is 0.97. From that point on, I can multiply and fill out the table. So that's the way I would approach this on a test when they don't give me the table to work